Good morning, students. Today we are going to conduct an experiment on wall timing diagram of a 4-stroke petrol engine. This is the tabular column. In here we are going to find inlet valve opening, inlet valve closing, exhaust valve opening and exhaust valve closing values. Here in this experiment we don't have the readings or angles on the circumference of this wheel. Instead of that, we are going to measure the length or circumference of the wheel, and using the circumference and also marking TDC and BDC using this formula where angle is equal to S is the circumference or the angle covered by the wheel and R is the radius, and multiplied by 180 by pi, you are going to get the angle through which this wheel has moved. These are the valves. This is an inlet valve and this is an outlet valve. When you rotate this wheel, the piston moves. So note down the TDC, that is the topmost position, and BDC of the piston, and then measure the radius of this wheel. Take a wire and measure the complete circumference of this wheel. Using a scale, measure the total length of the circumference, and by using the formula 2 pi r, measure the radius. Now we have come to know the circumference of this wheel. After knowing the circumference, because circumference is equal to 2 pi r, r is equal to circumference by 2 pi, you will get the radius. The radius here we have got is the radius measured from r is equal to 75.5 by 2 pi. We get the radius as 120.9. That is, radius is equal to 120.9. Take this line as a reference line for all the measurements. Now move the wheel. When the piston reaches TDC, mark this on this wheel. So parallelly mark this line parallel to this line. So you will see this is the TDC position. With reference to this, we will measure all the inlet opening, inlet closing, exhaust opening and exhaust closing. Now rotate the wheel and try to find the BDC, that is bottom dead center of this valve. Mark the BDC position with reference to the reference line. The distance between the TDC length, that is the circumference from the TDC to the BDC, from both the sides, from both the angles, it should be same. Then we are measuring it as correct.
BDC to TDC.
From TDC to BDC and BDC to TDC, the total length, that is circumference, should be 180 when we convert that and measure it. Now the position is TDC. We will find the inlet opening position. So we observe the inlet valve. When we move the wheel, we will see a slight opening of the inlet valve. So you see, so this is the TDC opening, slightly it is open. Then with reference to the reference line, mark the inlet valve opening. So this is IVO, inlet valve opening. So this is before TDC.
We are rotating clockwise.
So we are rotating this in clockwise direction. So this is an anti-clockwise direction. Now when rotating in clockwise direction, before reaching TDC, it is inlet valve opening.
Close.
This is an inlet valve closing. Mark this as IVC, that is inlet valve has closed with reference to the reference line. So we are going to measure the value of S, that is the arc length. So it is around 23 here, that is from TDC to IVO. Measure the value of IVC inlet wall closing with respect to BDC. Measure the length, that is the arc length, and how much is the arc length. Using the scale, you note down the value.
142.
The value is 142. Now this is the exhaust wall. We will note down the exhaust wall opening and closing values. So keep rotating the wheel.
Say before BDC.
So with respect to reference line, the value is before BDC. EVO, exhaust valve, has just opened in this condition.
Before.
Here EVO is before BDC. Next we will note down the closing of the exhaust valve. Keep rotating the wheel. Now you watch, here the exhaust valve has closed. With respect to reference line, mark the exhaust valve closing value. This is after TDC.
Because this TDC, then exhaust valve closed.
It is after TDC.
Around 20.
Measure the value with respect to TDC. It is around 20.
24. It's around
We have marked everything. You can note down exhaust valve opening is
49.
49. It is after.
Before BDC.
It is before BDC. Note down the readings. Respective readings: 23, 143. There is 23 is before TDC, 143 is after BDC, 53 is before BDC, and 29 is after TDC. Calculate the angle by substituting in this formula, where S is the arc length, R is the radius of this flywheel, and multiply it by 180 by pi. You will get the angles: 11 degree before TDC, 68 after BDC, and 26 before BDC, and 40 after TDC. Draw this graph with respect to BDC and TDC. So this radius can be of any radius. The radius can be of any value. There is no specific thing. Only you need to concentrate on the angles. This shaded part is angle of overlap. Note down the angle of overlap as the value.